Hello, this is the second part in the Making 2048 series. In this video, I'll be walking through making the game. So if you haven't seen the first part yet, I highly recommend that you should, since that is where I covered the topics that are necessary to make the game. So let's begin. So let's open up Idle, which we installed last time, and let's create a new file, and then I'm just going to save it real quickly as 2048. Okay, so the first thing that we should consider is what will happen at the very beginning of the game. So this is where we should start because this is the simplest aspect in our game. Because at the very beginning, all we will be doing is printing some text out and getting input. So on our file, let's print an intro statement. So such as, I'll say 2048 is starting. And this can be anything because it's just going to be the intro message when you run the game for the first time. So the next obvious step is to ask the user whether they want to move up, left, right, or down. And if you recall from last episode, we can do this by using the input function and then storing the input in a variable called move. So let's type that out. So input, we can say enter, or actually move up, right, left, or down, and then enter W, A, S, or D. So remember that it's always good to store the input somewhere so that we can later use it. So let's store it right now in a variable called move. Okay, so from here, it's a bit less clear on exactly what our program should do next. We know that we need to move the numbers in the grid depending on if they move up, down, left, or right. But right now we haven't actually implemented a board, or a grid, much less a way to move the numbers in the board. So since there's lots we need to do, the best thing we should do is break our game into the smaller parts. And that'll help approach the big task of coding the game, since we'll split it down into smaller parts. If you remember from last episode, one way of organizing our code is by using methods, and then the methods can designate the smaller parts. And this makes it easier because instead of having to, starting from the very beginning, we can kind of separate our code, as I said, into smaller parts, and then work on those smaller parts, and then eventually merge those smaller parts into our overall game. So if we go back to our file, let's create some methods at the top. There's no, or I guess it doesn't matter where we place the methods, but I'll put them at the top. So when we think about some of the methods that we'll need, the first one is obviously to print the board out, right? Because the user will need to know what the board is looking like at whenever they move. So we can create a method called print grid and leave it blank for now. So def print grid, and let's leave it blank for now so that later on we can implement it. Right now we're just trying to make all the methods that is needed, and then eventually we can actually fill out the code inside of them. So the next method that we'll need is have a generate method. After each move, a new number is placed in the grid randomly. So we can separate this function into a method since it happens after every turn. And it's a big part of the game, so we can split it up into a method. So let's call it generate and leave it blank for now. And again, if you don't know like the rules of the game, I'd highly recommend you check it out to understand exactly what we're trying to do. So the next obvious function is moving, because obviously the user needs to move up, down, left, or right, and these can be also split into different methods. So let's create 4 methods called shift right, left, up, and down. So let me do that real quick. Shift up, shift right, and again, think of using methods as kind of the actions in our game, right? Like the different things that can happen in our game. So printing out the grid is always going to be an action that happens. Generating new numbers is an action that happens. Shifting the board or the grid up and down and right and left are all actions. That's why we can split them up into different methods. And then the last one will be shift down. Okay, now that we made the plan, we should focus on the first thing that we should tackle. So all of the methods we have made so far revolve around doing something to the grid. So for example, printing out the grid, or generating a number on the grid, or shifting the grid. All of those involve using the grid, but as of right now, we haven't actually implemented a grid yet. And we know that our grid has 4 columns and 4 rows of 16 numbers, because in the game, that's how the grid is. There's 4 columns and 4 rows of 16 numbers. So as we discussed in our previous episode, using an array could help us deal with many numbers at once. But as we also discussed in the previous episode, using a 2D array will help represent the grid of 16 numbers more easily. That's because instead of having to deal with 4 separate arrays, we can just deal with one big array, I guess. So, so as we see in the image on the left, using a 2D array, in this case a 3x4 array, will look like a grid of 12 numbers with 3 rows and 4 columns. And on the right, I guess a different way of looking at it is we have one 2D array that contains one big array, and then each element in that array contains another array. So in our game, I think the easier way to visualize it is the one on the left. Obviously they're like the same, but just a different way of visualizing it. But in our game, it'll be similar to the one on the left, except instead of a 3x4 array, we'll have a 4x4 array. So if we go into our game, and let's see, at the top, we can create a 2D array. Let's call it grid. And each inner array, there'll be 4 inner arrays because it's a 4x4 array. Each inner array should be filled with zeros. In the normal game, each square with no number in it is blank, but in our game, I think having it set at 0 will make it more clear. So let's go back to, so let's create grid. So we'll have 4 arrays inside this big array. And then let's fill it out with the zeros. So 0, 0, 0, 0. Same thing here. And then here as well. So okay, so let's go back to where we got the input, which is right here. So at the beginning of the game, the user should know what the board looks like before they're asked to move, because obviously for the user to make a move that makes sense, they'll need to see the board and what it looks like. So let's call our print grid function or method. And again, right now it doesn't do anything, but we're just trying to, I guess, lay out the blueprint of our game for now. So after we get the input, we need to check if the input was either W, A, S, or D. And we can use this, we can do this by using if and else if statements. And inside each if and else if block, we could call the corresponding shift method. So let's do that right now. So if move, and remember to use 2 equal signs, is equal to W, shift up, elif move is equal to A, we shift left, and I'm just going to copy and paste this one for S and D. And then make sure to change this to the corresponding shift method. So if the user clicks S, it should shift down. And if the user clicks D or types D, it should shift to the right. Okay, so thinking about the order of what happens in the game, after the board shifts up, left, down, or right, a new number is generated. So let's make sure to call the generate method. So obviously right now it doesn't do anything, but later on it will. And I guess after this, the grid should be printed out again because I guess it's going to repeat now. At this point, we're trying to print a grid since the user just shifted a number, so they need to see the result of that. And however, if we print out the grid again, it'll simply be repeating what happened up here, where we called print grid. And furthermore, we should remember that these actions happen each turn. So all of this happens each turn. So we can't just copy and paste this over and over again. Instead, an easy way to solve this issue is to put this in a while loop. And let's do that right now. So if you highlight it and tab, you can put a while loop. And then for now, let's type in true in here. So typing in true for the condition will make this run an infinite amount of times for now. But later on, we can change this so that the game will stop when 2048 is reached, or when the board is full. So last thing that we need to remember is that at the beginning of the game, there's always two numbers, since if there wasn't two numbers, it wouldn't really make sense, because you can't merge two numbers when there's you have to merge two numbers at the beginning, so having one number wouldn't really make sense. So at the beginning, before we're in the while statement, let's type in generate twice. And yeah, just remembering that at the beginning, there's always two numbers on the board. And we don't put it inside the while statement because after each turn, only one number is generated. And we already implemented that down here. Okay, so this is where I'm going to leave this episode off. While our game isn't functioning yet, I can actually run it to show you what does happen. You'll see that it won't run because we haven't actually filled out anything yet in these methods. But we broke down the big task of making this game into simpler parts by creating methods that now simply need to be filled out. We also have our game loop set up, and we made our grid. And yeah, so what we did in this episode is very crucial in making any game, in fact, because without this organization and high-level approach, we would be doing a lot of trial and error, and our code would be confusing since it would not be organized at all. So yeah, this was a very important episode, and this is where I'll leave it off. However, I'll release the next part soon, and that's when we'll begin to fill out some of the methods, and our game will begin to start functioning after that episode. So make sure to leave a like on this video, comment if you have any questions, and subscribe, and I'll release the next part soon, and goodbye.